Hey everyone, and welcome to week 10. I'm sorry I can't be there in person. I'm not feeling well, and I figured it would be best if I ran this tutorial from home. So, in today's tut, we're going to be looking at doing a bit of code generation, and we're going to talk about the instructions of Jasmine, which is our assembly language. Now, Jasmine is an assembly language for the JVM. It has a one-to-one correspondence with bytecode, and there's no official assembly language for the JVM. So Jasmine is an assembly language. It is not the Java assembly language. And the reason that we use assembly instead of compiling directly to bytecode is because assembly does have that one-to-one correspondence with assembly, meaning that one instruction in assembly is equivalent to one instruction in bytecode. But working with bytecode means working with pure numbers, and working with numbers is not as nice as working with words. So let's get started. And I'm going to probably take a little bit of time to let you think about things rather than just jumping into everything. So that way we still have the thought provocation that I like to capture in tuts. So to begin with, we are specifying that we have a class test. So what do you think the first thing that we would want to say is? What's the first thing you should check when you're writing a class in Java and it's called test? The very first thing that you should do when you're writing a class in a file is make sure that the file has the same name as the class. So we'd have .source test.java. I'll make this a little bit bigger so it's all captured. And then we'll specify the class. And the next thing you need to do is you need to specify anything that test may be derived from. Is test derived from anything? And the answer to that is yes, test is derived from the object class, because all types in Java are derived from the object class. So what we say is we say super java /lang/object, which is the same as java.lang.object, but we use a slash here instead. Now, the next thing we need to do is start specifying the assembly for all of the methods. And on a first glance, you might decide that there's three methods, because we have int fi, boolean ff, and public static void main. There's another function. The first function that we're going to talk about is actually the constructor, because if we don't specify a constructor, then there is a default constructor that the compiler will synthesize for us, and that's what we're going to be using down here. So the first thing we do is we specify that. So we say .method init. This constructor is the default constructor, so it takes no values for parameters, and it doesn't return anything. So we say that it has a return type of void. Now, unlike in Java where we don't provide a return type for a constructor, in assembly we still need to specify that, because at the end of the day a constructor is still just another function. It's a special function in the source language, but in the target language that may not be the case. And just like we would do with braces, it's probably a good idea to put your end method at right now. So this opens a scope and this one closes the function scope. And then what we're going to do is we need to consider what data the or what storage space the constructor will need. So what parameters does the default constructor take? If you answered nothing, that's a perfectly reasonable answer to come up with, but the correct answer is 1. It has 1 parameter, and you never specify that parameter. It's the this reference that's included with all member functions. So what we want to do is we want to set our, because we're going to be interacting with the this point with the this reference, we want to have a stack space of 1, and there's 1 variable. So we say that we have 1 variable. Now, I didn't cover this earlier, but the JVM is a stack machine, which means that instead of having registers like you would on x86, or if you've done COMP3121, then the AVR machine that you've used, or the ARM processor that you researched, those are register-based machines that also have a stack. But the JVM is a purely stack machine, which means that we have a stack, and then we push our parameters on and pop them off to execute operations, and then we push the result back onto the stack. So there's no registers. And then what we say is we say that the first variable is this, and its type is ltest, semicolon, from label 0 to label 1. Now, so let's talk about this for starters. So this is the this parameter, and so it refers to the var 0 refers to the very first element in the array of parameters, and it's named this with a type of ltest semicolon. Now, we discussed yesterday about the L and the semicolon, and I didn't have an answer back then, but after doing a bit of research, it seems that the L is just a delimiter to say this is the start of a user-defined type, and the semicolon, because you can't have a semicolon in a class name, it delimits the end of the user-defined type. So the actual name of the class is just test. But because a class can have any name at all, we needed something to prefix the class with and something to end the class with. So if the class's name was actually ltest, then it would be double ltest. And then what we're saying is that the scope of this variable ranges from 0 to 1. Now what we do is we provide the label 0, and we say .line 1, which refers to the first line. Again, because it's a default constructor, it's not there, but so this is line 1. We'll come back to what this .line means in a little bit, but I think it's just best if we get through the default constructor first. So next what we're going to do is we're going to load the variable 0 onto the stack, and Alload will load the variable this onto the stack. And then what we're going to do is we're going to well, actually, I'll leave this to you guys. What would we do next? What do you do in any constructor that is a derived class? Well, the natural thing to do is to call the superclass that constructor. So what we do is we invoke a special function, which is why we say invoke special, Java lang object init. So we're basically going to be calling the base class's constructor, which happens to be just the default constructor for object. And then at label 1, we return, because all functions that are successful do need to return. And even though it's a constructor, we still need to return. Okay, so that concludes the constructor. Now we're on to this function, the fi function. So what we do is we say method fi I and end method. So this so fi is the name of the function. This I in here refers to the types that it takes as its parameters. So it takes 1 int and 2 int, and we just use I as the prefix for each integer, and then this one here corresponds to the return type. Now, for this one here, we need to think about what we need when we're computing stack size. So we need, every time we start a new function, we need to compute a stack size. And well, we have one operation where we're going to need some stack space for, and that's the comparison between I and j. So we need to push I onto the stack, and we need to push j onto the stack. So that means we need to reserve 2 variables for this. So we say limit stack2, and because there's 2 explicit parameters, how many local variables do you think there'll be? If you said 2, just think back to the constructor where even though there were no parameters, we had 1. But if you said 3, then you're on the right track. So there's 3 because we also need to include this parameter, locals 3. And then again, var0 is this L test from label 1 to label 2. And variable 1 is arg0 I from label 1 to label 2, and var2 is arg1 I from label 1 to label 2. Now you might be wondering, well, we've already used label 1. Can we? Are we actually allowed to use label 1? That was a source of confusion in the previous 2 tutors, and the answer to that is yes. You can recycle a label once you reach the end method section. Now, that's not a really something that we're going to spend too much time worrying about. Okay, so we start at label 1, and now we say line 4. Now, I want you guys to stop for a moment and just consider why it's a good idea for us to say .line 4 here. So line 4 is this guy, and the reason that we say that it's line 4 is so that way any runtime analysis tools can tell you where you are in the middle of execution. For example, a debugger. This is some meta information. So all the directives that start with a dot are just meta information, and the debugger will look at this and it will know that it's line 4 in the source file, so it can highlight this selected line and tell you that you're at line 4. Similarly, when we get to line 5, it'll be able to highlight this line and so on. That's also why sometimes you'll notice that the else section of when you're debugging is completely skipped. It goes from here directly to whatever's in the compound statement, in the statement below the else, because this is not always recorded. So what we do now is we load the first parameter and we load the second parameter. And how are we going to compare them? So if you said that we're going to compare them using less than like it is in the source, then what we need to do is we need to reverse the operations here, because if we're saying that it's going to be less than, then what we're going to do is if compare is less than, then we go to label 0, and that would mean that we'd have, so then what we would do is we would say line 5 I return, because what that will do is it'll return this line here. Well, it will return the oops, I forgot that one. Okay, I const 2. So it will return this line here, and then we'll return. And then we'd have label 0, and then we'd say I const 1, and that should be dot line 5, and this one is actually line 7 because we've put it down here. So what we've said is that if the comparison between I1 and parameter 1 and parameter 2 is less than, so parameter 1 is less than parameter 2, go to label 0, which means that we put this down here, which is a little bit confusing. It doesn't follow the structure. So instead what we do is we say if it's greater than or equal, we go to label 0, and we'll put this down here and put this up here, and we return and then we end the method. So just as a rule of thumb, when you're doing your comparisons, you need to invert the comparison operator when you're generating your code to preserve the structure of your code. So essentially what you're doing is you're testing for the else clause and jumping, otherwise you're just falling through. Now let's do the next method, which is ff. And so you may have noticed that I corresponds to integer. So if you guess that float will be f, that's correct. And I wouldn't blame you for guessing that boolean is b, but it's not, because there's another type that has b reserved. So we use the character z instead. And so that means that we return a z because it's a boolean as well. End method. And now we need to limit our stack. And so what size stack do we need? Well, we have this one that we need to push on, which is an I. And then we have the boolean that we also need to push on. And we have this 1.0 that we need to push on. So you might come to the conclusion that we need 3 spaces in our stack, but the answer is actually 4. And I'll come back to that in a moment, because there's something else that I want to cover in a moment, and if I reveal that now, it'll have a less of an impact in a bit. So we'll come back to that in a moment. Now the locals. Well, this one here is again 1, 2, and this reference, which is 3. We say var 0 is this ltest semicolon from label 4 to label 3, and var 1 is arg0 float from label 4 to label 3, and var 2 is arg1 boolean from label 4 to label 3. And then we start out with label 4 and line 11. And we load the float from register 1. And we say fload instead of iload because we're loading a different type. And because we're loading a different type, we need to provide a different instruction. Now, the next thing that we're going to do is, well, what do you think it might be? Now, if you said fconst1, you'd be like most people in the previous two tutes. However, that's not the correct answer. So the answer lies somewhere in this highlighted section, and no, it doesn't look like I can highlight. Okay, that's not a problem. So the answer lies between this section and float and 1.0. So if you just take a look at that for a moment and try to have a guess. Okay, so what's the type of I? If you said it's a float, then great. And what's the type of 1.0? If you said it's also a float, then well, it's actually a double. And we can't compare a float to a double because they're different types. So what needs to happen behind the scenes is that we need to convert one of these to the other type. Now, we can't convert 1.0 to a float because that means we'd lose information, we'd lose precision. But we can promote I, which is a float, to a double because that means we're not losing any precision. But you still shouldn't be comparing a float to a double anyway because of the way that the numbers are stored, and you'll end up with a few discrepancies. So what we do is we do f to d and then dconst 1. So it's a double of 1. Now, the reason that we have a stack size of 4 is because we push this one on, and then we push on this as 2. So it's a double, so it has twice the size of a float. And then we push on the boolean as well. So it's 1 plus 2 plus 1. And then we do a double comparison. So we compare if it's less because we're doing the greater than or equal to operation. So we invert it, which gives us the less than operator. And if it's compared with less, then what we do is that will pop these two parameters off and push a result onto the stack. And if it's less than 0, then we go to label 0. Otherwise, we need to check the boolean. And checking the boolean is very simple. We load it from the second. We load the second parameter, and if it's if the boolean is false, again the inverse of the condition, we also go to label 0. Now, you might have been wondering why we use iload and not zload, for example, because I think it's actually BA load, but or BO load, I can't remember. But the reason we use iload is because in order to have a small instruction set, we promote booleans, chars, bytes, and shorts to integers because we don't lose any information. There's no narrowing or loss of information when we can do the conversion. So we load it as an integer, we do the operations as an integer, and then we push it, then we store it as a boolean once we go and do the write. So the reads and operations are done to integers, but the writing is done as a boolean. And now what we do is we go to line 12, and line 12 is just I load 2, so we load the boolean again and we return. And then for label 0, we need to do a few things, because we can't just say return not B. We can't just negate whatever the value is. We actually need to do a bit of testing. Now, I can't say this is the way all assembly languages work, but this is the way that the JVM works. And so what we need to do is we load the variable and we test it. So if it's true, we go to label 2. Otherwise, we load the value and we go to the returning label. And then in label 2, we load the false value, and then label 3 we return. So what we've done here is we've tested it to see if it's false. If it's false, then we return true. So we load that onto the stack. We go to the returns instruction, and we return what's left on the stack. If it's not true, however, if it is true, then we'll go to label 2, where we load the false value onto the stack and return that instead. So this is just a manual way to check if manual way to execute the not operation. Pardon me. Okay, and now we're on the home stretch, because we have just one function left, and that's our main function. So once again, method, and then what we do is we provide the access specifier, the storage specifier, the linkage specifier. Then we have main, and in order to specify an array, we have the open bracket. So that's it. That's how you say an array. An array is prefixed by the open bracket, but there's no closed bracket. Then we say ljava /lang string semicolon and v. So what we've said here is we have a class called string that's inside the package java.lang, and it's an array. And then we have an end method. Okay, so I want you to think about what the stack size of this is and what the local size is. So the stack size is actually 4, and we'll get to why it's 4 in a bit. And the local size is 2, and once again we'll get to that in a little bit as well. So what we first say is that what is var0? Okay, so if you said it's the first argument, which is the set of strings, you're correct. And the reason it's not the this parameter is because it's a static function, and functions with static linkage don't have a this parameter. So we say it is arg0 of type java /lang string from label 0 to label 1. And then at label 0, which is on line 19, we push a new test onto the stack, and then we duplicate it, which means that we pop off new test. We pop off the test we've just pushed on, and then we push on 2 more of the same. So we now have 2 objects of new test, and we then call the constructor. And then what we do is we store that into into what would be T. And now on line 20. So before we move on, this is where 2 of the objects for the stack are found. Now on line 20, what we need to do is we need to state that we are getting the static function system.out.println. So we take the static function and that's from the print stream class. Then what we do is we load our first variable, which is T, and we also add the values 1 and 2. And then we call the function fi. So we invoke the virtual function test fi, which takes the parameters 2 ints and returns an int. And so what that does is it pushes these on as the parameters. So this is var 0, this is var 1, this is var 2. If we were to scroll up and take a look at fi again, we have this, which is T, arg0, which is 1, and arg1, which is 2. And then finally we invoke the function println, and so it takes an integer and it returns nothing. So that means that we've evaluated the expression and we're now passing it to println. And then we have on label 1, so not label 1, line 21, essentially the same stuff. So instead we're going to be returning a boolean, and we take different parameters. So what we'll do is, to save a bit of time, we'll copy this out and we'll modify it as necessary. So we still need to get the static function. We still need to load T, and we need to load a constant float. So 2.0f, fconst2. We need to change this so that way it resembles true. So iconst1 is the same as true. And we need to call a function ff with fz, which returns z. And we need to call the print line for that takes a boolean. So this is the equivalent for line 21. So they're very similar. You'll notice that they're almost the same. It's just the type information and the instructions here that really do change. However, the differences are extremely important for the meaning of your program to be preserved. And then finally, we have label 1, and on line 22, which is this line here, we need to return. And that's it. So I've answered question 2 in this demonstration. So that was way back up when I explained why we have iLoad instead of zload. And if you have any questions, feel free to shoot me an email. I'm always available, and thanks for taking your time out to watch this instead of going to the tute. Once again, apologize that I wasn't able to be there in person, and I'll see you guys next week. Thank you.